These are the mixed stoichiometry notes. It will be helpful to have a periodic table available and a calculator. Our goal here is that we're going to be able to convert between moles and grams of any compound in a balanced equation. So that could be going from moles to grams, grams to moles, or we could be doing mole to mole or gram to gram, any of those combinations. A reminder of our stoichiometry chart. This is available on the back of your periodic table that I have linked on Schoology. One thing to note on here, we don't cover particle stoichiometry calculations just because they're not very useful. Grams are useful in a lab setting, which is why we focus on converting with between moles and mass. But we could just as easily include particles because we know that mole particle relationship. So you should be using this, and again, we've got our number of moles of A equaling number of moles of B. That's how we are writing that mole ratio using our balanced equation. And then we also have our 1 mole equals molar mass relationship on either side. I put a periodic table in here in case we need to use that for finding molar masses. All right, so we are given a balanced chemical equation, and this is basically the recipe of our reaction. So the hardest part with these is kind of figuring out where are we starting, where are we ending. We could have 1, 2, or 3 steps based on where we're starting and where we're ending. If it's gram to gram, it would be 3 steps. If it's grams to moles of something else, it would be 2 steps. If it's mole to mole, it would be 1 step. So any of those could be our options, 1, 2, or 3 steps. All right. How many moles of Fe2O3 iron oxide are produced when you have 56 grams of iron? So when I'm looking at this, sometimes it's just identifying your start and your ending point can be tricky. So we have 56 grams of iron, and this problem is asking us for moles. So we're looking for moles of Fe2O3. If we go back up to our chart, we can look and see, okay, we're going from grams to moles of something else. So this is going to take 1, 2 steps. Remember, when all else fails, we want to get to moles of whatever we are starting with if we're not already there. All right, so I'm going to write down my given, 56 grams of iron. And to get to moles, we can go back and look at our chart, or I know the mole-molar mass relationship, which is here, and I'm going to set that up with my grams of iron in the bottom of my conversion factor, and that 1 mole in the top. And we know that 1 mole of iron is going to equal the molar mass. So we can go to our periodic table and find iron. Iron is right here, 55.85. We generally will just round, so 56 would be that nearest whole, and that's our first step. If I was to end here, I'm at moles of iron, but I need to get to moles of iron oxide, because we're going from, again, those moles of iron and to moles of iron oxide, and so now I need that mole ratio to use my kind of recipe or my reaction to figure out what is the relationship between each of those. I have my moles of iron in the top. I want to get rid of those. Remember, often with when we're setting these up, these conversion factors, what we want to get rid of in that step goes on the bottom. What we want to end up with is going to go in the top. And so we're wanting to end at that Fe2O3. So I'm going to put my moles of Fe2O3 in the top. I am getting rid of, changing from moles of iron. And my values now for that are going to come from my coefficients. I have 2 moles of iron oxide and 4 moles of iron in that equation. And then those are my 2 steps. So my step 1 was here, step 2 is here, and so now I can go through and do my calculation. Again, when we're setting these up, looking at my grams of iron and grams of iron, my units canceled here, my moles of iron, my moles of iron, my units canceled here. And so we are left with the unit we were asked for, moles of iron oxide. That's what we were asked for here. And we can go through and do that math. I like to just multiply anything in the numerator. So 56 times 1 times 2. So that's 112 divided by, and I need to multiply everything in the denominator. So that is 56 from that molar mass times 4. And that is 224. And then I can do that 112 divided by 224. And I get 0.5. There's my value. I need units, moles, and then the chemical Fe2O3 for my final answer. All right, let's do the next one. How many grams of Fe2O3 are produced when you have 4.5 moles of oxygen? So we're starting at moles of oxygen, going to moles of iron oxide, going to grams of iron oxide. So moles of oxygen 2, this one's asking for how many grams of Fe2O3. So moles of one thing, 2 grams of another thing. If we go back up to our chart and look at how many steps that's going to take, well, we are starting in this one. We are starting here and ending here. So now this is going to be 1, 2 steps, but our first step is going to be using that mole ratio, and then we're doing a mole to mass conversion second. As I look at setting this up, I've got my given value, 4.5 moles of O2. Thinking of doing those conversions, well, both of these have moles in them, but I'm at O2. I don't want to go to grams of O2. I need to switch from O2 to iron oxide. So I'm doing my mole to mole, my mole ratio first. I want to get rid of O2 and change to iron oxide. So that moles of iron oxide is going to be on the top. Going to our coefficients, we have 2 moles of iron oxide to 3 moles of oxygen for that mole ratio. And then this one is asking us to continue from moles of iron oxide to grams of iron oxide. So we are then going to use our 1 mole is molar mass relationship for that. 1 mole of Fe2O3 on the bottom. Finding my molar mass for that iron oxide, I've got 2 irons. Each iron is 56 plus 3 oxygens. Each oxygen is 16. And so I've got a molar mass of 160 grams equals 1 mole. So we have our 1 mole on the bottom, 160 grams on the top, and we can go ahead and do our calculations. So doing my calculations, I'm going to just multiply my numbers in the numerator first. So 4.5 times 2 times 160, which is 1,440. And then I need to divide by 3 times 1. So dividing by 3, 1,440 divided by 3, I get an answer of 480. That's my value. And then I need my units. This asks me to find grams of iron oxide. That's the unit and chemical on the top of my last conversion factor. So grams of Fe2O3 is that last piece we need in our answer. All right. If you're feeling comfortable, feel free to try the next couple on your own. Otherwise, I'm going to go through these. How many moles of iron will be produced from 21 moles of iron oxide? So we have a different reaction here. So making sure we're using our new balanced reaction. We're starting at 21 moles. of Fe2O3. This is asking us for moles of iron. And anytime we have a mole to mole, that means we're just going to need to use that mole ratio conversion. And so this one is going to be one step. And we can see that if we go back up to that chart as well. Writing out my given, I have 21 moles of Fe2O3. I want to get rid of or change from moles of Fe2O3, and I want to get to moles of iron. And so I then can go up to my reaction. I have 1 mole of Fe2O3, I have 3 moles of iron, and so I need to put those values in. 21 times 3, that's going to be 63. And then moles of iron is how much will be produced from our 21 moles of iron oxide. How many grams of iron are produced when you have 4.5 moles of magnesium? So starting with 4.5 moles of magnesium, going to grams, figuring out how many grams of iron. And so with this one, we're going to have to go moles of magnesium to moles of iron, and then we're going to have to go to grams of iron. And so this one is going to be a 2-step with that. I showed this in our gram to gram notes, but if you want to show each step, if you want to show each step individually, I could have 4.5 moles of magnesium, and I could show that going to moles of iron in one step. So I would have my 4.5 moles of magnesium using my mole ratio, moles of magnesium on the bottom, moles of iron on the top. Going to my reaction, I have 3 moles of iron, 2 moles of magnesium, and I could do that step. I have 4.5 times 3, and then divided by 2, I get 6.75 moles of iron at the end of that first step. And then we do need to go through and do that second step, which would be to go from our 6.75 moles of iron to the grams of iron that our problem asked for. So 6.75 moles of iron, well, that gram to mole relationship, I'm going to put my 1 mole of iron on the bottom so that I can get rid of moles of iron, which means my molar mass in grams is going to go on the top. Using our periodic table, iron has a molar mass of 56. And then I can do my math. 6.75 times 56 divided by 1. And we get our answer, 378. And then we need those units, grams of iron, to finish our answer. If you showed your work all in a single step, you should still get that same 378 grams of iron. You do need to show your work to demonstrate your learning when you are being assessed on these. All right, one more. And again, feel free to pause if you need. How many grams of magnesium oxide? So we're looking for grams of magnesium oxide. That's our MgO. Are produced when 12 grams of iron are produced. So both of those are products. So that wording is a little tricky, but that doesn't matter. We still are going to just do that gram to gram conversion, and this one is going to be 3 steps. And you can look up at that chart if you need. So I'm starting with my 12.0 grams of iron. When all else fails to go from iron to magnesium oxide, I need to first get to moles. So I'm going to use my 1 mole is molar mass as my first step in that conversion. We need to get rid of grams because that's what we currently have. So grams of iron goes on the bottom, 1 mole on the top, and our molar mass is 56, getting that from our periodic table. Our next step then, we are at moles. So I'm at my moles of iron. I need to get to my moles of magnesium oxide. So I'm going to have my moles of iron on the bottom. I need my moles of magnesium oxide. So that's going to go on the top. So we're using our mole ratio and getting those values from our reaction. I have 3 moles of iron and 2 moles of magnesium oxide. So those go into my second step, which is that mole ratio. Last step then, this is asking us for grams of magnesium oxide. And so our third step is going to be, again, to use that 1 mole is molar mass. We'll have 1 mole of magnesium oxide on the bottom and our grams of magnesium oxide on the top. To find that molar mass, we are going to do 1 magnesium, so that's 24, plus an oxygen, which is 16, so that has a molar mass of 40, so 40 grams on the top. Again, that was that same gram to mole relationship we had in that first step. So those are our 3 steps. Now that we have that set up, we can go ahead and do our math. 12 times 1 times 2 times 40, which is 960, divided by 56 times 3 times 1, which is 168. And then 960 divided by that 168 gives me 5.714, and that continues on. Let's round to 1 decimal place, 5.7. That 1 is going to keep that 7 in the 10th place. And then we need our units, grams of MgO. All right. For practice, there is a mixed stoichiometry check-in for you. There is also a worksheet with an answer key provided. There is a pivot, stoichiometry backwards and forwards, that you do need to complete, and reach out to your teacher with any questions.